Chain rule. The chain rule is one that will trip you up if you're not careful. So this is section 3.1, I believe. So let me just make sure. Over here, 3.1. Okay. So section 3-1. And so if we're doing the chain rule, it's where it's used with a composite of functions. So it's used when there's a function within a function. So something like f of g of x. And there could be multiple things inside. But when you're taking the derivative, remember that's the derivative notation, of a composite of functions, what we do is we do the chain rule. The chain rule goes as follows. There's an outside function. F is the outside function. G is what I would call the inside function. So the derivative of the composite of functions is you take the derivative of the outside function and you leave the inside function unchanged. Then you multiply by the derivative of the inside functions. So it's like you're stripping this down layer by layer. The best thing I can tell is differentiate the outside, leave the inside alone, then differentiate the inside, attach them with multiplication. And so this is when you have a function within another function. You're going to need the other trig rules. I kind of went over them a couple days ago. The derivative of the tangent of x is equal to the secant squared. The derivative of the cotangent of x is equal to I want to make sure, I just want to do a quick thing and make sure that that I write it down right. So just bear with me just for a second. Let me just make sure that I get this right. I don't want to do it wrong and then have you guys go, wait a minute, that's not what you told us. Yeah, it's negative. So this is negative cosecant squared x. The derivative of the secant x is equal to the secant x times the tangent x, and the derivative of the cosecant x is equal to negative cosecant x cotangent x. Just as a side note, I want you to note that the sine squared x is the same thing as the sine of x squared. So that's going to be important as you start to do chain rule, just where that squared really goes. The math notation is to put the squared after the sine, and it just means we're taking the sine times the sine. So remember, this doesn't replace the product rule, doesn't replace the quotient rule, doesn't replace any of the other rules. Any of these rules that I just went over, they don't replace any rules. They're just added to all the other rules that you have. Now I'm going to go through about 12 different examples. So buckle up, because this is just example city over here. Okay, so if I'm taking the derivative of this, notice that this is a 1 that is in front of there. That's a constant multiple. We just keep that there. But notice that negative x is the inside function. Cosine x is the outside function. So in our chain rule example, cosine would represent f, and negative x would represent g. So if I'm differentiating this, the negative 1 comes along. When I differentiate the cosine, it's negative sine. I leave the inside alone. But now I have to differentiate the inside. The derivative of the value of x is just, or negative x is just negative 1. So this is fine if you wanted to leave it that way, or you could simplify it, and since you have 3 negatives there, you got negative sine negative x because of all the negatives in this one. Okay? Let me do another one. Let me do more before you freak out. So let's take this one. If you look at this one of the things that you'll notice is this is the sine of 4x. So if we differentiate this, we're going to use the chain rule. The derivative of the sine is the cosine. We leave the 4x alone, but then we have to differentiate 4x, which is just 4. So if you think about like this in terms of the chain rule. In terms of the chain rule, this is f of g of x. So this is f prime of g of x times g prime of x. If you think about how we did that. Okay, so let's do another one. Example 3 here. That 5 out in front, that's just a constant. So if we're going to find the derivative, dy dx is equal to, if we bring the 5 down, or we have that 5 out in front. Now, we're going to bring the 5 down. We're going to leave all of this alone, negative 6x squared minus 7x, but we're going to do it to the 4th power because that's the power rule, times. Now we have to differentiate the inside. Derivative of the inside is negative 12x minus 7. You can leave it in that form. These things will be messy, but that's where you're going to leave it. Okay, let's do another one. Take something like this one. dy dx, remember that stands for derivative. Bring the 4 down. Leave the inside all alone. Reduce the power by 1 times. Now we have to differentiate the inside, which is 4x minus 4. And you should be familiar with those, with the power rules, because those are something that you should just know how to deal with. Okay, so let's take this one. Now we got a negative exponent. It says we can leave it in any form, so I think delta math will allow you to not have to simplify. So if that 2 is there, but I bring the 3 down, so now it's going to be negative 6 in front. We have x plus 7. This is going to be to the negative 4 if we reduce it by 1. And the derivative on this one is 1. The derivative of x plus 7 is just 1. You wouldn't necessarily need to write that 1 there. Okay, so this one, remember, I talked about it. F of x is equal to negative 2 cosine x squared. That's another way of writing that one. So if I now differentiate this, f prime of x is equal to negative 4, because I bring that power down, cosine x to the 1st power times negative sine x. And we would need to put that parentheses around the negative sine x, otherwise it might be mistaken for subtraction. Okay, I don't know if they'd simplify that, but you could certainly easily simplify it to 4 cosine x times sine x. That'd be a pretty easy simplification on that one. Okay, that's example 6. It's 12 examples. Example 7. Remember that on this one, y can be written as 4 times the cosine of x, all raised to the 1/2 power. because of the square root. So if we differentiate it, dy dx is equal to, if we bring that power down, 4 times 1/2 is 2. The cosine x to the negative 1/2 times negative sine x. Okay? So hopefully that makes some sense. Let you copy that one down. Okay, this example 8 gets a little bit trickier because there's actually 3 inside functions on this one. So know that if I had you differentiate something like f of g of h of x, what we would do is we differentiate the outside, leave the inside alone, then differentiate the first inside, then we differentiate the last one. Okay, so that's what this one is going to do. Okay? So if we have this one, we're going to differentiate this. Dy dx is equal to, so the sine is the outside function, so we're going to differentiate that first. Cosine. We're going to leave x squared plus 4 to the third alone. Now we're going to differentiate the x squared plus 4 to the third. So we bring that power down. We got x squared plus 4 to the second. Then we have to differentiate the x squared plus 4 as just 2x. Okay, so that's number 8. Take a pause that for a second, replay that one if you need to. Okay, so let's go to this last one, or this next one. It's just not the last one. Remember y in this case, it's -1 sine 3x minus 1 to the fourth. That's another way to write that particular problem. That fourth is the sine is to the fourth power. So when I differentiate this, the -1 is just a constant. Bring the 4 down. So if you wrote that as -4, that's fine. Sine 3x minus 1. That's to the third now. Now I have to differentiate the sine. Derivative of sine is cosine. I leave the 3x minus 1 alone. Then I have to differentiate the 3x minus 1, 3. So, you know, a multiple choice might simplify this into -12 sine cubed 3x minus 1 times cosine 3x minus 1. There's probably a trig identity in there that we won't do, but there probably is a trig identity that when you go to college, your math professor will want you to do. But I'm just going to leave it like that. So this is dy dx. So one of those, one or the other. All right, example 10, cotangent. So this is f of x equals the cotangent of x to the second power. So if we're going to differentiate this, f prime of x is equal to 2, and then we have cotangent x to the first power times, now we have to differentiate the cotangent. If you go back up and you look at what the derivative of the cotangent was, it was negative cosecant. So negative cosecant squared x. So maybe you'd write -2 cotangent x times cosecant squared x. Okay, 2 more examples and then we're done. All right, so now if we're going to differentiate this one, the 2x is inside, so dy dx is equal to the secant squared of 2x times 2 because of the inside. That's another inside-outside one. All right. So the last one, and you might have to go pause these and go back and look. Oh, maybe that's it. Maybe that's all I did. 11 examples. Oh, I did 11 examples. So that's it. Hopefully that makes sense to you. Go back and review these and check them out again and see what you don't understand and assignments on Delta Math, and then you should be good.